Earth's atmosphere is a relatively dense mixture of roughly 78% nitrogen, 21% oxygen, 0.93% argon, 0.04% carbon dioxide, and a small scattering of other gases. Some of these gases, principally water vapor, carbon dioxide, methane, nitrous oxide, ozone, chlorofluorocarbons, and hydrofluorocarbons, have unique physical properties that allow the absorption and admittance of thermal radiation. These gases are commonly called greenhouse gases because they let in most of the solar radiation from the sun that heats the Earth's surface, but then turn around and trap part of the outgoing thermal radiation that bounces from the Earth's surface, effectively preventing our planet from having an average temperature of 0 degrees Fahrenheit. Too much of a good thing can be bad, though. In the last 150 years, or since the beginning of the Industrial Revolution, human activity, mainly through industrial pursuits, has exponentially increased the amount of greenhouse gases within the Earth's atmosphere. This exponential increase in greenhouse gas emissions leads to a disastrous positive feedback loop called global warming. As more greenhouse gases are added to the atmosphere, in this example carbon dioxide, the warmer overall Earth becomes. As the Earth becomes warmer, evaporation rates increase, which cause more water vapor to be released into the atmosphere. As water vapor is itself a greenhouse gas, this cycle becomes self-fulfilling. While you may already be familiar with the concept of global warming and what a greenhouse gas is, you may or may not be familiar with what the main drivers of this global phenomenon are. According to the EPA, as shown here, the number one global greenhouse gas emission by overall tonnage is carbon dioxide. Furthermore, if we take a look at the global emissions by industrial sector, we can see that energy production far outstrips any other sector for overall emissions. By diving a little deeper into those numbers and comparing individual fuel sources by their carbon emissions to their energy production capabilities, we can gain a little more insight into what fuel sources are most likely to have the most impact on global warming. As quoted here by the U.S. Energy Information Administration, we can see that coal emits the most carbon when it is burned for energy, followed closely by diesel, gasoline, propane, and natural gas. One place where a person can quite literally see the disastrous atmospheric effects of burning coal for energy is in Beijing. China is the world's biggest consumer of coal, accounting for 26% of global consumption. Additionally, it is also the world's third largest energy producer and the second largest energy consumer overall. China is estimated to emit 13% of global carbon emissions from fossil fuels, second only to the United States, and this share is projected to rise to 18% by 2025. There are over 150 coal-fired power plants in China, and that accounts for roughly 77% of the country's energy needs. This rampant use of coal to meet the country's electrical needs has some disastrous effects aside from the global warming implications. In 2013 alone, 366,000 premature deaths in China were directly attributed to the burning of coal. The World Health Organization noted in a 2004 study that only 31% of Chinese cities met the WHO standards for air quality. Also, a study by the World Bank in 1997 valued health damages from air pollution at 5% of the country's GDP. So where does China and the world go from here? For many years now, there have been ongoing international talks to address the growing greenhouse emission levels worldwide. International agreements started in earnest with the United Nations Earth Summit in 1992, which aimed to stabilize emission levels at then historic levels. And these talks have continued to the present time with Paris Climate Accord. Continued engagement in such talks is paramount to a clean energy future. Additionally, promising advancements in clean energy production via wind and solar energy and the continued diversification of major energy-producing countries into those sectors provide a glimmer of hope for the curtailment of greenhouse emissions on a large scale. Having said that, fossil fuels still remain the cheapest upfront means of large-scale energy production.